Hello, welcome to today's video where we're going to be introducing the chapter of correlation. In this particular video, we're going to be focusing mostly on the terminology needed in this particular area of maths, as well as how to deal with the more wordy based questions, rather than focusing on the more calculation based questions, which is something we'll focus on in the future. And without further ado, let's start getting into explaining some of this terminology. First of all, starting off with bivariate data, because bivariate data is the sort of data we're going to be looking at in this chapter, and it is specifically data that's got two variables in it, but specifically where those two variables are always given in pairs. So for instance, a good example of that is coordinates, where you've always got an x value given with a y value, but it doesn't have to be x's and y's, it doesn't have to be coordinates, it could be any two letters, any two variables you like. But the advantage of that is it always can be then plotted because they can be treated like coordinates, so therefore they can be plotted on a scatter graph. Now, I'm not going to patronize you by spending ages talking about plotting scatter graphs, because it ultimately is just treating the two variables like coordinates on your particular scatter graph and then plotting them, and I'm sure you can do that. Other key terms you need to be aware of include things such as knowing what an independent variable is, which for those of you who have done any sort of science education have probably already come across before. But it's basically this idea that if somebody's doing some research or experiments or even just collecting data, the independent variable is the variable that the person carrying out the experiment might be choosing to change, might be choosing to control and see what happens when they do that. The independent variable is then usually plotted using the horizontal axis on your scatter graph. We also need to know what a dependent variable is, and hopefully you're aware that that is the variable that's measured then based on the independent variable values that were chosen. The dependent variable is then usually measured on the vertical axis. These two things also do have alternative names. The independent variable sum is called the explanatory variable, and the dependent variable sum is called the response variable, and this is starting to get into the sort of situation where you know one of the things is causing the other thing, because then it makes sense why you call them these two new names, because you're talking about the variable that's causing the change being the explanatory variable, and then the other variable is responding to what that first variable is doing, hence why it's called the response variable. But once we've plotted the bivariate data on a scatter graph, what then? Well, often people choose to plot things on a scatter graph so they have the chance to see visually if there's a relationship between the two variables. And this is where correlation comes in, because correlation is specifically a measure of if the two variables have a linear relationship or not. There's two main types of correlation. If your data looks like this, then it's said to be positively correlated. And that's because the linear relationship that you can start to see forming with your data has got a positive gradient. Whereas if your data looks like this, then it's described as having a negative correlation because the linear relationship has a negative gradient. But there's also different levels of correlation, different strengths of correlation. For instance, if your data looks like this, we'd call this a strong positive correlation. And that's because we're getting to the stage with the data points where it's almost looking like they're lining up in a perfect straight line. But if the data is a bit more spread out, but still vaguely linear, then we'd call this a weak positive correlation. There's enough of a pattern there for you to be able to see that it's going up and to the right as we travel along the scatter graph, but not enough to have a nice sort of neat straight line there. So that's why it's weak positive correlation. And if the points just keep on spreading out more and more to the point where you've got something that looks like this, well, at this stage we can't really see any discernible pattern. So therefore we describe this as no correlation. And these same sort of descriptors can then be applied to negative correlation as well. You can have strong negative correlation, where the data points are once again lining up nicely, but with a negative gradient this time, and then a weak negative correlation where they're still lining up in a way that looks like they're going down as you travel to the right, but again, they're a bit more spread out than before. So that's the terminology you need to be aware of, but we need to know how to answer word-based questions to make sure we're answering with the correct terminology. So for instance, here is an example. We've been given some data and apparently it's been collected from markets in 11 towns in France, and they had recorded how many kilometers the town was away from the coast and also how much seafood was bought at the market in each of those circumstances, and they've then plotted that on the scatter graph. Important things to note is they have labeled the axes so we know which variable has been plotted where, even though we don't have enough of a scale to actually read off the individual data points themselves. So, part A, they've asked us to identify the independent variable. Now, there's two clues for answering that. First of all, just by looking at the horizontal axis, there's a big clue of which one of them it's going to be, because we said the independent variable is usually plotted on the horizontal axis. But the other aspect is just from how the words in the question have described the scenario, which is that they decided to collect the data from markets in 11 towns, which is implying they chose which 11 towns it was. So therefore, the independent variable is going to be the distance from the coast. Part B. Really key word in this question is it asks us to describe the type of correlation. This is not to be confused with what they're asking us to do in part C, which is to interpret the correlation. Describe implies just having a one-word answer wouldn't be enough, but equally we're not having to go into detail relating it to the context, because that's more of what the word interpret means. So therefore, describe the correlation means just to basically say what type of correlation we have, but therefore the things I might want to include there is what type of correlation we have and what strength of correlation we have. So for instance, in this situation we can see as we're going to the right, it's going down in general, and so therefore it's going to be a negative correlation, but the data points aren't too closely grouped together in a nice perfect straight line, so therefore I'm going to call this a weak negative correlation. On to part C, where we're now having to deal with the question that does ask us to interpret the nature of the correlation. Now, knowing exactly what an examiner would want from a question that says interpret would obviously vary exam board to exam board, from qualification to qualification, but I would take the word interpret to mean basically relating the thing you're talking about back to the context described in the question. So therefore, in this case, we're not just describing the type of correlation, because obviously that was part B. We're instead trying to make the correlation make sense in layman's terms in relation to what the original question was describing. So in this case, yes, we already know it's a negative correlation, and therefore we've already identified this idea that as you go to the right, the data is generally traveling downwards. But therefore we can say pretty much that, but then actually using the wording and terminology and variables described in the question. But therefore the way I'd write it is that as the distance of the town from the coast increases, the amount of seafood bought each month decreases. So therefore watch out for that, the difference between the describe and interpret questions in this chapter, because they are looking for different things. Obviously, if you're in an exam and worst comes to worst, just put both of these types of answers that I've written down in answer to the question, but obviously that is wasting time if you're doing that, so it is better if you give the correct answer for the correct type of question that's been asked. However, there is one other big thing we do have to watch out for when it comes to correlation, which is that correlation does not imply causation, which in layman's terms means that just because two variables are correlated doesn't mean that one of those variables is directly causing the other variable to change. So what impact does this have when we're trying to answer questions? Well, this is difficult for me to give specific advice about, but I would say just in general, when answering exam questions, you just have to use some logic or common sense about the scenario being given to make a conclusion about whether or not there is a link between the two variables involved in terms of if one of them's causing the other or not, because there's three different sort of scenarios that can happen ultimately. Either one variable is directly causing the other to change, or neither variable is causing the other to change. It's the case that both of them are related by a third currently unidentified variable that's causing both of them to change at the same time. Or the third option, which is that ultimately, although both variables are changing in the same way, it is completely by coincidence, and although there appears to be a link between them based on the correlation, there is no causal link between them. And so looking at some examples so that you can see some scenarios of those three cases in the real world. So for instance, scenario 1, ice cream sales are strongly positively correlated with daily mean temperature. In this case, it would be a fair conclusion to make that these two things do have a causal relationship, because ultimately when the temperature gets hotter, people are more likely to crave something that's cool. So ice cream, of course, being a food with a colder temperature, is more likely to be sought after in those sort of conditions. So there we go, that's one example. A second scenario, the cost of bread in a supermarket over time and the cost of cake in that same supermarket are positively correlated. In this case, we've got to be careful. Are we going to be able to say, just because these things are correlated, that the cost of cake immediately causes the cost of bread to go up? Well, no, not one of those two variables causing the other one directly. What's the case in this situation is probably there is a third variable causing the costs of both of these things to go up or down at the same time. For instance, the cost of any ingredients that they might both happen to share, or the cost of food in general going up due to production or transport costs. So, although they are positively correlated, it's not that one of these things is directly causing the other. And on to the third scenario, covering the third case, which is that controversially, the popularity of the name Wayland in the US and the total wind power generated in China are positively correlated. And no, that is not a joke. They actually are positively correlated. Here's a graph showing that. And ultimately, what conclusions can we take from that? Well, not much really. They are linked by a relationship to each other. If we look at a more traditional scatter plot to show that correlation more clearly, you can see there is a linear relationship between them, but that doesn't mean that one of those two things is causing the other. It is, for all intents and purposes, a coincidence, probably. And so therefore, that's why you've got to be careful about just going, oh, there's a correlation, therefore one thing is directly causing the other. In reality, in the real world, correlation is often just used as a way of narrowing down what things should be investigated further, rather than a final conclusion sort of situation. It's just a sort of way of scientists, for instance, to be able to go, oh, look, okay, these things are worth investigating to see if there is a reason behind why one thing is causing the other, rather than actually the correlation itself telling you that one thing is causing the other. And by the way, on that topic, I'd recommend checking out the website tylervegan.com, because on that website there's loads of what's called spurious correlations that appear like they are telling you that there's a link between two things, but in reality they aren't. Really very interesting, because lots of random variables on there that you can show to be correlated, even though they're clearly not actually causally linked. And that's something I would say in general about statistics. If you just view statistics as a bunch of things you're answering for exam questions, then it can end up appearing a lot more dry as a subject and less interesting than it really is. In the real world, it's hugely interesting because you're getting to investigate things and see what's going on, and therefore the more you can relate statistics to doing that sort of thing, the better. So this is a good example of a website doing this for correlation, showing why we've got to be careful with it. To be clear, I am not sponsored or receiving any money from this website. I'm generally just recommending it as a just interesting thing to look at. The link to spurious correlations, tylervegan.com, will be in the description of this video, so check it out. And with all that said, that is us done for this video. So as I said, this video was mostly just focused on terminology and how to answer wordy questions, but we will have a future video more focused on the calculations side of correlation still to come. So look forward to that video. See you later. Goodbye.